Questions 21 through 25 on the 2012 grade 11 Fermat math contest. If x squared is equal to x times 8 plus y and y squared is equal to x plus 8y with x not equal to y, then the value of x squared plus y squared is. Several approaches to this question. I'll give you the short way. There's a longer way too, but obviously on math contests you want to do it the short way so you can save time. X squared minus y squared is what I'm going to look at. A little bit of a technique here. If you substitute that, just using what they've given me in the question, I get 8x plus y minus x plus 8y. And this is 8x plus y minus x minus 8y. And this becomes 7x minus 7y. And if you factor out a 7, you get x minus y. Now, x squared minus y squared, as you are well aware, can be factored into x minus y, x plus y. Now, since x does not equal y, these are not going to be zeros, so I can get rid of them. Divide through by both of them, and all I'm left with is just x plus y is equal to 7. Okay, so this is a very helpful piece of information. And now I can concentrate on what they want, which is x squared plus y squared. Using these two definitions, let's add them now. X squared is 8x plus y, and y squared is x plus 8y, and this is 9x plus 9y. If I factor out a 9, I get x plus y like this, and x plus y is 7. So substitute that in, and this becomes 63. So as you can see, in a quick way, I can get the answer. Number 21, therefore, is C. In the country of no hills, each pair of cities is connected by a straight and flat road. The chart to the right shows the distances along the straight roads between some pairs of cities. The distance along the straight road between city P and city R is closest to. Well, P and Q are 25, whatever the units are, 25 something, meters, kilometers, so let's say that's P and that's Q. And I was staring at this, and immediately these numbers made me think of, and I'm sure even you figured it out, a Pythagorean relationship, right? Because 7, 24, and 25 is definitely a Pythagorean relationship. So that's why I immediately figured out that this has got to be a triangle, a right triangle in particular. Okay, so let's move forward. P and S. P and S is 24. So I believe that is probably going to be one of the side lengths. And then we've got Q and S is 7. Okay, so that means from here to here is going to be 7. Now this isn't drawn to scale, but that's okay. Let's label this now. PQ was 25, PS is 24, and SQ is 7, right? The distance from P to Q is 25, the distance from P to S is 24, and the distance from S to Q, or Q to S, either way, is 7. And this does indeed work out to be a Pythagorean relationship, because 24 squared plus 7 squared is equal to 25 squared. Now there's one other city that I have to put in, that's R. Now R to S is 18. So that means I've got to extend this line, and it's got to go 18 like this. So this is R, and this is 18. And that means RQ, from R to Q, is 18 plus 7, which is 25. Let's see, R to Q is indeed 25. So great, it matches. So now my task is to figure out the distance from P to R. So that should be pretty straightforward using Pythagoras. PR squared is equal to 24 squared plus 18 squared. So that's going to be 576 plus 324, and that is 900. So therefore PR is the square root of 900, which is 30. So number 22, the The answer is A. A bowl contains 320 grams of pure white sugar. Mixture Y was formed by taking X grams of the white sugar out of the bowl and adding X grams of brown sugar to the bowl, and then mixing uniformly. In mixture Y, the ratio of the mass of the white sugar to the mass of the brown sugar expressed in lowest terms was W to B. Mixture Z is formed by taking X grams of mixture Y out of the bowl, adding X grams of brown sugar to the bowl, and then mixing uniformly. In mixture Z, the ratio of the mass of the white sugar to the mass of the brown sugar is 49 to 15. The value of X plus W plus B is... Well, before I dive right in, I'd like to explain this in a way that you understand it. So I'd like to use some numbers first, and then I'll get into the solution. So initially, there's 320 grams of this white sugar, WS, white sugar. And then what you do is you take out a certain amount of sugar. So I'm just going to give some values just for illustration purposes. Let's say the amount I took out, X, is 50. I take out 50, so now there's 270 grams of white sugar remaining. So 320 minus 50, which is 270. Correct? Now, in addition, I've got to add X grams of brown sugar. So X is 50, so I'm going to add 50 grams of brown sugar. Okay? So this is scenario Y, mixture Y. Now, let's talk about this whole WB business. How do they figure that out? Well, in my example, the amount of white sugar is 270 now, and the amount of brown sugar is 50. So my ratio of white sugar to brown sugar would be 270 over 50. And in lowest terms, that's 27 over 5. And this is my W over B. Okay? Now, since we're done with that, we move on to mixture Z. Mixture Z is formed by taking X grams of mixture Y out of the bowl. So this bowl right here, we got to take X out. Now, how much was in here, first of all? It was 270 plus 50. There's 320. So we're taking X out. So from the 320, we're taking out X, which I have designated as 50. So I've got 270 left. Now, the 270, though, we have to talk about that before we move forward with the question. This has to be broken up into white sugar and brown sugar. How do we do that? Well, you look at this ratio. From the 270, 27 over 32, right? Because you have to add them. 27 plus 5 is 32, is white sugar. So 27 over 32 times 270, that's how much white sugar is in this. So it's about 227.8 approximately. And then to get the amount of brown sugar, it's going to be 5 over 32 times 270. And that's approximately 42.2. All right, so we have in this bowl now 227.8 of white sugar. We have 42.2 of brown sugar. And then now we can go back to the question. Add to that X grams of brown sugar. So X was 50, so 50 grams of brown sugar. Okay. Now they're saying they have to figure out the ratio of the white sugar to the brown sugar. In our case, it's 227.8 over 42.2 plus 50. So that is going to be 227.8 divided by 92.2, and that's approximately 2.47. All right, so I hope you understand. I just did this to explain how this question goes, because if I immediately start going into W's and B's and all that, it might be too abstract. It depends on the person. But if I explain it with some numbers, at least you have an understanding of what is happening. Now, in this question, they've told me that once I get to this step, that ratio has got to be 49 over 15, which is approximately equal to 3.27, right? So it's not what I got, but that's because I chose x equal to 50. We have to figure out the actual correct value of x so that gives this ratio at the end. Okay, so now that I'm done with this example, I will proceed with the exact same scenario, but to make it easier to understand, I'll work right here with this diagram, these diagrams that I created. So here we go. So now we're starting with 320 grams of white sugar, which is fine. Now my x, I don't know, so I'll get rid of that 50. Now, again, I've got to get rid of the 50. I don't know what x is, so instead of writing x, I will just put the symbol. And similarly, because it's not 50, I have to just put in x. Okay, so far so good. No tricks. All right, now let's move forward to the next part. This is no longer 270, it's 320 minus x. Correct? And that denominator is no longer 50 because I don't know what is the value, so I have to just put in x. And we can get rid of this 27 over 5. But this is equal to my w over b, 320 minus x over x. Okay? And that is the first step. And I will call this equation 1. I am going to have to use it later in order to calculate the values for x and w and b. All right. Now let's move forward with the next part. The next part I had written 320 minus 50, right? Well, 50 was what I had given the value for x, but I don't know x, so instead of 50, I will write x. Now, therefore, I have no idea what this number is, so I'll just get rid of it. But this part, this is important. This is probably a little bit challenging, so we got to talk about this. This was 27 over 32, but how did I get that? I got it over here with that w and b. But now I've got to change that. It's not going to be 27 over 32. It's going to be w over w plus b. Right? And in this bracket, it's not 270, it's 320 minus x. 320 minus x. And of course, I got to get rid of this. I have no idea what it is. In a very similar way, I've got to figure out the brown sugar. This, of course, what I just did was the white sugar, WS. Now I got to figure out the brown sugar. Well, very similarly, get rid of that. It's going to be B over W plus B. So we've got B over W plus B. And of course, I got to multiply by 320 minus X. And this is my brown sugar. So going back to this diagram, I think I'm going to have to increase the size here to fit in the numbers. So I've got, let's see here, white sugar is going to be W over W plus B times 320 minus X. And brown sugar is going to be B over W plus B over times 320 minus X. But also don't forget that in addition to this mixture, we are adding X grams of brown sugar. So in addition, we have to put in X right here, like that. And that completes our equation. And then now we move to this part here, which has to be completely erased because we have to now figure out the ratio of the white sugar to the brown sugar. And that is going to be W over W plus B times 320 minus X, that's the white sugar, all over the brown sugar, which is 320 minus X times B over W plus B, and then plus X. And this is equivalent to what they've given right here, which is 49 over 15, like that. So I wanted to do it in a thorough way to help you understand it, because otherwise it becomes pretty abstract really quickly, and it may not be of any benefit. Okay, we're still not done, and we just got the equation. We have to go through this equation. Now remember, this was equation 1, so this monster is equation 2. And we have to figure out the solution for these two equations. So here we go. From equation 2, if we cross multiply, we get 15 times W over W plus B times 320 minus X. And on the other side, we would get 49 times 320 minus X times B over W plus B, and plus 49X, like that. Multiply through everything by W plus B, and we get rid of that fraction, and this will just be 15W 320 minus X. This, if you bring everything over on one side, it would be 49 times 320 minus X times B, and this will be 49X times W plus B, like that. And then now we can just expand it all out, and if we do, we get 4800W minus 15680B minus 64XW is equal to 0. I expanded it all out and collected like terms, right? And now this can also be divided through by 64, and when you do, you get 75W minus 245B minus XW is equal to 0. All right. So at this point, it's much simpler, and now we can substitute that guy in there. But before we do, we have to rearrange this equation a little bit before I can substitute it. This one here, I'll do it down here. If I cross multiply, I get 320 B minus XB is equal to XW. Put the x's on one side and factor, and you'll get W plus B, like that, and then isolate for x, and you get 320B over W plus B. And then that is very helpful for us. That will allow us to substitute there for that x. So at this point, I can substitute 75W minus 245. There's a B that's missing there. And then put in the x and get 320B over W plus B times W. Multiply through by W plus B, and you get 75W times W plus B minus 245B times W plus B minus 320 WB is equal to 0. If you multiply this all out and collect like terms, you will get 75W squared plus 75WB minus 245WB minus 245B squared minus 320WB, and that is equal to 0. Let's see here, collecting like terms. Actually, this is divide through by, what can I divide through by? I think 15. Or, I think 5, not 15. 5 is the only thing that goes through. That's okay. 15W squared minus 98BW minus 49B squared. I've collected like terms. And then this factors, and let's see here, just W, 15W, 7B minus plus. And that means that W is equal to 7B in order for this to work and to give us positive values for W and B, right? Because all the values represent a certain amount of sugar, so they can't be negative. So this is very, very helpful. We can now use that to figure out x. Remember, this is my original equation, so that means 320 minus x over x is w over b. Well, if w equals 7b, then w over b will be equal to 7. So this is just going to be 7 right here. All right. So now we just cross multiply, and we get 320 minus x is equal to 7x. And therefore 320 is equal to 8x. And therefore x is 320 divided by 8, which is 40. So x, we got 40. Now we have to figure out w and b. Well, we can substitute that into any of these formulas, I bet. Or even quicker, we know that w is equal to 7b. So we can just choose a value. For example, if b is 1, then w will be equal to 7. That's perfectly valid. So therefore, our final step is to figure out x plus w plus b. Well, it's going to be 40 plus 7 plus 1, and that is 48. And the reason I know that it's most likely this is because they have told me that this is in lowest terms. So that's why w over b is 7 and over 1. So 48 is my answer. Let's go back to the original question. Number 23, therefore, is A. In equilateral triangle PQR, S is the midpoint of PR. T is on PQ, so that PT is equal to 1, TQ is equal to 3. Many circles can be drawn inside quadrilateral QRST so that no part extends outside QRST. The radius of the largest such circle is closest to. Well, let's label this as best as we can. We've already got a lot of these labeled, so let's continue. PT, they tell me, is 1 and TQ is 3. PS, well, S is the midpoint of PR. Since it's equilateral, all the sides are equal to 4. So if PS is the half, since S is the midpoint, PS is 2. And if we were to label the angles, this has got to be 60 degrees up here. It's equilateral, right? So, and if you were to draw a line straight across like that, then you will clearly see that from here to here is 2, and that would be 1. Now this line cuts that in half, so that means this must be a right angle. So I put that right angle in there. And if that is 90, then this little guy in here is 30 degrees. And therefore this is a 30, 60, 90 triangle. So this is root 3 in terms of that distance. This is 60, this is 60, this is obviously 90 since that's 90. And this angle is 150 since it's supplementary to the 30-degree angle. So there we go. We got a little bit of a start to this question. Okay, so now that we labeled all of this, we have to now do the same sort of thing, but now we have to involve circles. So I want to bring in another circle, another diagram, I should say, in order to avoid making the diagram too messy. So we have to figure out, how is the circle going to be placed? Where is it tangent? And that's the challenge of this question. As you can see, it's not going to fit in a way that is tangent to all 4 sides. So it's probably maximum going to be tangent to 3 sides. So we have to deal with certain cases. So the case number 1 is what I'm going to first show, which is this scenario, where the circle is tangent to 3 sides, and those 3 sides in this specific example are obviously ST, TQ, and RQ. So this is sort of my my starting point, and then I will build an equation with this, and then I'll apply that equation to the other cases. So here we go. Let's draw some lines now. Let's draw some tangent lines from the center of the circle to the edges of the circle, and of course those tangent points will create right angles. And now let's create some triangles joining the center to the vertices of the triangle, like that. And then I've got to label some angles in here. So I will call this theta, and I will call this theta, like that. And these two angles in here, I will call alpha and alpha, like that. And of course, these guys are the radii of the circle. So now we have to look at the relationship of tan, and in particular tan theta. So tan theta, as you know, is opposite over adjacent. So if we look at this triangle right here, it's going to be, or a better triangle to look at is that one, since we're going to eventually look at this triangle. Tan of theta will be equal to r over this side right here. And I haven't labeled anything yet, but I'll just call this m right here. So it'll be r over mq. And similarly in this triangle, if we use tan of alpha is equal to r over tm. And then we can, of course, isolate for mq and tm. mq will be r over tan theta, and tm will be r over tan of alpha. But tm plus mq, right, tm plus mq is that whole side right there, which we know is 3. So add them up, mq plus tm, which is 3, is the equivalent of r over tan theta plus r over tan of alpha. And then what we'll do is we'll just isolate for r, and instead of 3, I'm going to call that base, the base of sort of my diagram, and you'll sort of understand why, because it will change. And I don't want to put any numbers in. I did initially just to sort of show why I can combine them, but I'm going to call it base. And then I just isolate for r, and I get this not too terrible of an equation, tan of alpha. So this is case number 1. In case number 1, what is my value for r? Well, I have to substitute, obviously, my values for alpha, theta, and base. Well, base in this case was 3, right? This is going to be my fundamental formula throughout the question. 3 and alpha, if you've forgotten, you can get from here and here. So alpha is going to be, 2 alpha actually is going to be 90, so alpha will be 45, and 2 theta will be 60, so theta will be 30. So let's substitute those in. We got 1 over tan 30 and 1 over tan 45. And if you do this math, you will get r is equal to approximately 1.098. Okay, so I hope so far that's clear, that there's nothing confusing. This was for case number 1, when the circle was tangent to these 3 sides, ST, TQ, and RQ. So now we're going to do the exact same thing, but 3 more cases. This was case number 1. I'm going to do case number 2, case number 3, and case number 4. And they all involve that same formula. The only difference is the sides that the circle is tangent to. Now I've got to look at case number 2, case number 3, and case number 4. Now case number 2 involves a circle that is tangent to the following sides: P PQ, QR, and RS. Case 3 will involve a circle that's tangent to QR, RS, and ST. And case 4 will be a circle that's tangent to RS, ST, and TQ. Now some of these are, as you can see when I draw the diagram, not possible. But that's because I've got the aid of this software. On a paper and pencil test, you may not have the aid of this software, so you won't be able to clearly see it, but I'll explain it. First, let's do case 2. A circle that's tangent to PQ, QR, and RS. As you can see, it extends beyond that quadrilateral, right? It extends beyond STQR, that quadrilateral. So this is not possible. But despite the fact that it's not possible, I'm still going to calculate the radius. And I calculate the radius with this formula that I had figured out before. It was R is equal to the base over, if you remember, 1 over the tan of one angle, in this case was theta, and over 1 over the tan of the other angle. Now, we have to figure out what is the base and the angles. It's not the same as the previous question. This time, those numbers are a little bit different. This is the base this time, RQ. And RQ, if you remember, had a value of 4. Now, this is my theta this time, and this is my alpha. Well, if you go back and see, this whole thing was 60, so theta has got to be 30. So it's 1 over tan of 30. And then if you go back, you'll see that this is also 60, so alpha is also 30. So this is my calculation for R this time. And if you get out your calculator and you do this math, you get 1.154. Okay. Now, this value is unfortunately inadmissible. Why? Because a circle cannot be drawn like that. I did it because I wanted to be complete, but it's no good. Our first one was fine. If you go back to this one, you can definitely draw a circle that is tangent to ST, TQ, and RQ. And when you do, you get a value of R of 1.098. But the one I just drew now, this unfortunately is not a circle that can be drawn. You can't draw a circle that is tangent to PQ, QR, and RS. So even though we calculated the value, it's not admissible. So let's go to the case number 3, a circle that's tangent to QR, RS, and ST. So as you can clearly see there, that is possible. And let's just do our triangles again. And of course we got the same formula, but now we have to figure out what are my values for theta, alpha, and base. They're not the same, right? This time my base is from here to here, from S to R. And if you recall, the side length is 4 and S was the midpoint, so that base is 2. And this time my, say, alpha can be here, this little guy right there, and my theta will be here, that angle in there. So if you go back, you'll notice that that was 60, so alpha's got to be 30, so this is 1 over tan of 30. And if you recall, this angle was 150, so that means theta is 75. So this is tan 75. So 1 over tan 75 and 1 over tan 30. And if you do that math there, you get 1 for a value of R. And this is a legitimate value because a circle can be drawn and have it be tangent to QR, RS, and ST. So now let's look at the last scenario. First and foremost, we got to draw a circle that's tangent to RS, ST, and TQ, and then figure out the radius. Well, as you can clearly see, that sort of a circle cannot be done. You can't make a circle to fit in that quadrilateral and still have it tangent to RS, ST, and TQ. But that's okay. Let's just figure out the radius anyways. Same formula. This time the base is from here to here. And we had previously calculated that as root 3. And this time you can call this alpha. And if you remember, that was 90. So alpha is going to be 45. So I get tan 45. And this time, or theta. And this time our alpha will be this guy in here. And this whole thing was 150. So alpha is going to be 75. So this is my formula now. Root 3 over 1 over tan 75 plus 1 over tan 45. And if you do the math there, you get 1.366. And as described in the diagram, that's inadmissible. There's no way to draw a circle like that. And yeah, that's it. So as you can see, the only admissible values are r equals 1. And the one I got at the very beginning, which was r equals 1.098. And of those two, the largest is the 1.098, which is closest to 1.1. So number 24, the answer is B. There are many positive integers n with the following properties. The digits of n include at least one of each of the digits 3, 4, 5, and 6. The digits of n include no digits other than 3, 4, 5, and 6. And the sum of the digits of n is 900, and the sum of the digits of 2n is 900. When the largest and smallest possible values of n are multiplied together, the number of digits in the resulting product is. Well, let's first make a little table here. We have n, 2n, and we have the sum of those digits. Well, when n is, say, including the number 3, 2n will be 6. And the sum of those digits obviously are 6. When it's 4, 2n would become 8, and the sum is 8. But when you have 5, and you multiply it by 2, it becomes 10. The sum of the digits of 10 are 0 plus 1, which is 1. And then if you have a 6 and you multiply it by 2, it becomes 12. And the sum of the digits of 12, 1 plus 2 is 3. So that small table gives me the following conclusion, that if I just have n and I have a certain number of them, say I have w 3s, I have x number of 4s, y number of 5s, and z 6s, the sum is calculated as 3w plus 4x plus 5y plus 6z. And they tell me in the question that sum has to be 900, the sum of the digits. Now let's look at 2n. This was for n. For 2n, in a very similar way, if I have w6s and x8s and y, resulting in 10 because I have 5 y's, and then I had z6s that result in 12s, the sum is calculated as follows. It would be 6w plus 8x plus 1y plus 3z. See, I have w3's, but when you multiply it by 2, it becomes a 6. And that's why I have to use w times 6, because 6 is the sum of that number. The sum of the digit of 6 is just 6. If I have x 4's, when I multiply it by 2, it becomes 8. So now it becomes 8 times x. Y 5's, well, when I multiply by 2, it becomes 10. The sum of the digits of 10 is 1. That's why it's y times 1. And finally, if I have z 6's, when I multiply by 2, I get 12. The sum of the digits of 12 is 3. That's why the sum of the digits of 2n is 3 times z. And that's what I have here. And that is also 900 according to the question. So these are my two equations that I originally are able to make just with the information in the question alone. So now let's call these something. Let's call this, say, equation 1 and equation 2. And then let's start manipulating these. So say 2 times equation 1 minus equation 2, I think will help me out. I get, let's see here, 6w plus 8x plus 10y plus 12z. And if I subtract, I get minus 6w minus 8x minus y minus 3z. And on the other side, it would be 1800 minus 900. So the good news is the w's and x's go, and all I'm left with is 9y plus 9z is equal to 900. Divide through by 9, and I get y plus z is equal to 100. So this is a very important finding. If y plus z is equal to 100, then that means I can substitute that back into this original equation to simplify it a little bit. That becomes 3w plus 4x plus 5y plus, I'm going to break up that 6z into 5z plus z, and that's 900. So this becomes the 3w plus 4x plus 5y plus z is 900, and then y plus z is 100, so I can substitute that in and just get 3w plus 4x plus z, and then bring the 500 over to the other side. So this is my second equation. Now, at this point in the question, we have to start talking about what it is they want us to maximize and minimize. They want us to find two values of n. The first is n max, and the second is n min. The maximum value of n and the minimum value of n. Now, for each of these, the sum of the digits will be basically x plus w plus x plus y plus z, like this. So if the number has w 3s and x 4s and y 5s and z 6s, the sum of those digits is x plus y plus z, w plus x plus y plus z. And therefore this one has to be first maximized, and we also have to find the minimum possible value and the maximum possible value. Now y plus z we already got as fixed as 100 right here. So that means this really just boils down to finding that. So since y plus z is fixed as 100, we really just need to be worried about w plus x. We have to first maximize w plus x and then minimize w plus x. So it makes it a little bit easier for us. So that's what we're going to concentrate on, trying to find the maximum value of w plus x and then the minimum value. So first let's concentrate on figuring out the maximum, and then we'll figure out the minimum value. So let's use this equation, since that's one of the only equations we have. We've got 3w plus 4x plus z is equal to 400. I'm going to factor this 3 times w plus x, and then put the z and that 1x over to the other side. Now, we want to maximize w plus x, right? This is what I have to do here. So if I want to maximize w plus x, that means I've got to minimize z and x. So to maximize w plus x, I have to minimize z and x. Well, if you recall, there has to be at least one value of each of those numbers. So x has to be at least 1, and z has to be at least 1. X was representing the number of 4s, and z was representing the number of 6s, if I recall. So what's the minimum? Well, I can choose 1, but if I choose 1, what will happen for z and x is I won't get a number that is divisible by 3. See, watch what happens. I get 400 minus 1, and it's got to be divisible by 3, and unfortunately it's not. Okay, no problem. Instead of 1 and 1, how about if I choose 2 and 2 for my values of x and y? If I do that, then I get 396, and 396 is indeed divisible by 3. Because remember, all of these have to be integers. They represent the number of digits. So w plus x, therefore, if I divide through by 3, is 132. So the maximum value of w plus x plus y plus z is 132 plus y plus z, which is 100. So that's 232. So I just got my maximum value. That's the maximum number of digits in a number n, where the sum of the digits is equal to 900. And the sum of the digits of 2n is also 900. Now we get to the next one, which is minimum. So in the same way, I have to take this and minimize my value for w plus x. So same scenario, but now I'm looking for a minimum. So what I'm going to do this time is factor again. I'll get w plus x, but I did a little bit of fancy algebra there, so I have to add w to this side. That's the only way I could have gotten this. In this equation, if I want to minimize w plus x, I have to maximize my z, and I have to minimize my w. Now let's look at the parameters. W is got to be greater than or equal to 1. Z also is greater than or equal to 1. But if you recall, y plus z was equal to 100. So that means z has an upper limit of at least 99. Because y has to be at least 1. So y being at least 1 leaves that z has to be at least 1 less, so it can be maximized as 99. So let's do that now. Let's maximize z and minimize w with these parameters. And when you do, you get the following values. Z, we can use 99. But the minimum w, if I try 1 or 2, this will not become something divisible by 4. So the first time it works is when you use w equals to 3. And when you do, you get 4 times w plus x is equal to 400 minus z, which is 99, plus w, which is 3. And this becomes 301 plus 3, which is 304. And therefore, w plus x is 304 divided by 4, which is 76. So the minimum value of w plus x is 76. So therefore, w plus x plus y plus z, that will be 76 plus 100, because y plus z was fixed as 100. And that's 176. So this is the minimum value for this number of digits for an n that has the properties in the original question. So now we have to take the n max and then multiply it by the n min and figure out how many digits are there. Well, the number of digits in n max is 232. The number of digits in n min is 176. We calculated that here and that here. Well, when you multiply two numbers together, you take the number of digits in the first and the number of digits in the second and add them to figure out the number of digits in the product. So that's how you figure out the number of digits in the product. And 232 plus 176 is 408. And that is the answer to the question. So number 25, the answer is A.